Good morning everyone, I'm Daniel. The topic we are going to report today is the impact of tires on climbing. Have these questions ever come to your mind? Why is every off-road vehicle provided with massive tires? Why do you have to hoop and poof while walking your bike after encountering a giant slope? This is our catalog. We will first give a brief introduction about our assumption and experimental procedures. Eventually, we are going to summarize our conclusions as well as discuss about the hardship we will confront with during our empirical results. Summary: in our experiment, we used electric motor cars to simulate road vehicles. After that, we calculate the time the motor cars spend climbing up the slopes. We also made a thorough discussion about the influence of climbing ability which different size tires have under the same circumstance. Motivation. Our motivation originates from several simple machinery mechanisms we have learned before. For instance, the principle of leverage, axles, gears, and bevels. The mechanisms mentioned are applied in our experiment, especially when converting plain electric motor cars.
Next on, let's take a look at the formula shown above. The chassis force generated by the vehicle is equivalent to engine torque, multiplied by speed reduction ratio and transmission efficiency, divided by the driving wheel's radius. As you can see, this question includes quite a few proper notes. Hence, we can just simply comprehend it as the chassis force is disproportionate to the wheel's radius. In other words, as the radius declines, the vehicle climbing ability increases. Nevertheless, this is only theoretical. There is a considerable number of factors that may potentially impact the vehicle climbing ability in real life. Different motors, pavement, wheel size, wheel materials are just a few examples. We couldn't take every element into account, so we endeavored to eliminate other factors and focus on the influence that different size tires had on the vehicle climbing ability in consequence. 下一页哦。Equipment. We assembled two electric motor cars using chassis, tire, board, materials, and electric drills. They process a large tire and a small tire, respectively. This is our result.
Variables. Our independent variables are tire size and steep slope. The control variables are the material of the slope and the climbing distance. And the dependent variable is the climbing time. And this is what we're going to record. Process. As you see, there are two kinds of gradient, and the gradient of the tire is different. The purpose obviously is to make the slope steeper, and we will record the time to figure out which will last longer. Results. These are our experimental data. Look at the bar chart. We could easily find out that no matter how steep the slope is, tires with bigger radius last longer. And look at the second chart. We got the same result. Okay, the last. Although the data is quite close, but still, bigger tires last longer.
8. Discussion. Tires with smaller radius take less time while going uphill, and it is consistent with our assumption. It can be clearly seen from the above experimental results that small tires can climb in a short time regardless of different size of slope, which is in line with our experimental hypothesis. After this experiment, we confirmed that under the same power source and road conditions, the size of the tire does affect its climbing ability. Finally, we came to the conclusion that with the smaller radius it has, the more climbing ability it will receive. Problems. There were some timing errors in the 3 experiments. We believe that those problems probably due to battery depletion. From the results, it can be observed that from the first to the 3rd experiment, the time has gradually increased. Although we use a larger battery to avoid it, there is still a slight gap. In addition, during the experiments, we often see the problem of the car's path deviation. This may also cause errors in these experiments. In the future, we can also discuss the tire material and other factors that affect car traction, and find out which tires are suitable for each road. That's all. Thank you for your attention.